So we're going to have a look at the last three questions in this video. So we're going to write out our equation, speed is distance over time. The question here actually asks us to calculate the time taken to travel from London to New York. So we're going to insert some numbers. So the speed was 690 meters per second. The distance, now because we put the speed in meters per second, we actually need to put the distance traveled into meters. So that needs to be 5,600, but then to convert from kilometers into meters, we're going to multiply by 1,000. And then that gets divided by time. So we need to rearrange this. So the simple way of doing it, we just swap t and 690 around. You can go through the multiplying both sides by t and dividing both sides by 690 if you want to. But we can shortcut it by just dividing, just swapping the 690 and the t around. So we've got 5,600,000. And we're dividing that by 690. So the answer we get is 8,116 if we round it to 4 sig figs now. Sorry, that shouldn't have gone up there, should it? Because that number should go down in the evaluation box down the bottom. So that number should have ended up down here. That 8,116 should have ended up down that time equals. And so then we need to check the significant figures. Well, we've got 2 or 3 sig fig in that, and we've got 2, 3 or 4 sig fig in that. So we can probably put this to 3 significant figures. So that to 3 significant figures is 8, 1, 2. Oh, the units. Well, the units, we had a a distance in kilometers, distance in meters, and we divided it by a time in meters per second. So the units are going to be seconds there. Is that plausible? Well, we probably want to do a quick check. We could divide it by the number of seconds in an hour. We could divide it by 60 and then divide it by 60 again. And we get 2.25. Yeah, that's plausible, I suppose. I think the world record for Concorde travelling from New York to London is 2 hours 52 minutes. So a little bit longer, but obviously this isn't accounting for the fact that Concorde has to speed up and slow down and navigate around other aircraft. So I'm happy that's a plausible calculation. We've done that. Okay, so if you want to check anything on there, you may need to pause this because I have to clear it to scroll down. So last 2 questions. We've got Usain Bolt doing some running in this question, and we're asked to find the time taken again. So speed is distance over time. We're going to insert some numbers. The speed was 12. The distance is obviously the 100-meter race, and we're interested in how long it might take him. So we're going to have to rearrange that. Dead easy, we swap the 12 and the t around when they're in that position in the equation. 100 divided by 12. We're going to evaluate 100 divided by 12, and we find the answer is 8.3 recurring. Now, we don't want to see this recurring number in physics. So you might write down a little bit of it here before we consider the significant figures. What do we want? Well, we've got 2 sig fig here, and we've got maybe 1, 2, or 3 sig fig there. The smallest number that we're definitely sure of is 2. we want this to two significant figures. So time is 8.3. The units, well, we had a speed in meters per second and a distance in meters. So that's going to end up giving us a unit of seconds, 8.3 seconds. Is that plausible? Well, it's a little bit faster than the world record, isn't it? But don't forget that Usain Bolt doesn't start at 12 meters per second. He has to do some acceleration to get there. So, yeah, I think that's pretty plausible. Final one, we're asked for the time taken for a bird to fly a certain distance. So we've got a speed of 4.5 meters per second. We've got a distance of 50 meters. And we've got our time that we're being asked to find. We've got to rearrange, same pattern. We swap the t and the 4.5. So 50 divided by 4.5. We can get our calculator and work that one out. And we're going to get that the time is 11.1 recurring. So we need to check sig figs again, because we don't want this recurring number as an answer in physics. So we've got 2 sig fig there, and we've got 2 sig fig there. That's 1 or 2, 50. But 2 sig fig, so to 2 sig fig, this is just 11. The unit, well, we had a speed in meters per second and a distance in meters. That's going to give us a time in seconds, 11 seconds. But plausible for a bird to fly sort of length of a football field? Yeah, I think so. Okay,